So if you looked at a cuboid and a cone, and now we're looking at a cylinder, and the important point to read here in bold is that it's an open top base, an open top one, so we don't have a top here at all. So when we're talking about the surface area is made up of the bottom of this bit here, which will be the pi r squared, plus the curved surface area. Now the curved surface area is all the way, it's a rectangle, it's all the way around the outside of that, which is the circumference of the circle times by the height. Imagine unwrapping a label off a can or a bottle and think that actually the labels are rectangles. So that is the area that we've got, and we've been told that the surface area of this is actually just 48 pi. So I'm going to write 48 pi equals pi r squared plus 2 pi r h. There's a pi in everything, so I'm going to cancel out the pi in everything. And the question's asking us to find out what h is. So I've got my h here, so what I'm going to do is I'm going to do the 48, take away the r squared, and that gives me that, and then divide both sides by the 2r, gives me that h is 48 minus r squared over 2r. Now the volume of a cylinder, the volume is pi r squared h. No 1/3 this time because it's not a cone. And we know that h is this thing here. So we've got 48 minus r squared divided by 2r. There's a bit of tidying up to do here, and you can see there's going to be two parts to it. So this first part, let's look at this. 48 divided by 2 is 24. We've also got an r squared divided by r here, which gives us an r, and there's a pi outside it. So there's the first part, and that's exactly what we were looking for here. Minus because of here. Now, here I've got all of this bit here. So I've got r squared times r squared is r to the 4, divided by that r there makes an r cubed. We've also got a pi, and this time the 2's on the bottom. So I could write over 2, but I'm going to write a half there, just like we've got here. And so there is the expression for the volume. We're going to need to differentiate that thing. dv by dr. Now, even if you couldn't have done that first bit, we're just looking at this expression here, and we're differentiating it. That's just got an r there, so that disappears when I differentiate it, and we're just left with 24 pi. Here I'm timesing by the power, and the power's going down by 1. So I've got 3 pi over 2 r squared. To find out when it's its maximum, we want this to equal 0. I'm going to add that to both sides. I'm going to get a bit more space to do this with. And what am I going to do? I'm going to times by 2. Times them by 2 will get me 48 pi. I'm going to divide by 3 pi. Divided by 3 pi there and then will just give me 16. So I've got r squared equals 16. So I've got r equals plus or minus 4. Well, you couldn't have a radius of minus 4. Not possible. And so the radius that we want is a radius of 4. And that would give the maximum. We can check that we've got the maximum by doing the second derivative of this. The second derivative of this is going to be minus 3 pi times by r. I've got that because that's just a number, it's going to disappear. There's the minus here, times by the power, the 2's cancel out, so I've just got 3 pi r, and if r is equal to 4, then that is going to be negative. Therefore, it's definitely the maximum.